All right, let's go ahead and get started tonight. I'm happy that this was an easier chapter for you guys, like kind of an easier thing to start Thanksgiving break off with. Yeah, and you know what? Regression is in a similar vein, which you will get to do this week. It is literally, if you can select the right data and properly identify whether it's the X or the Y, you're gold on regression. Yeah. So you have done, other than the review, you have learned to build all the difficult, complex models you're going to have to in this class, okay? This one is more about interpretation of the data, as is regression. So if you can give it the right inputs on this one in regression, like I said, you're good. Before we dive into tonight, I want to take a minute and address some of what I saw as the common mistakes when I went through and graded your work. The first one that I commented on a lot this week is that EMV is not the same as your expected return, okay? EMV is expected monetary value, and it is a way to assess the given the potential returns along with their risk. So for instance, in the tire plant, a lot of you were telling me that your expected return on the tire plant was $15,000. Are you ever going to make $15,000 in your expected solution? Okay. In the case of the tire plant, you would have, if the market expanded, what would you would have made $250,000, right? If the market stayed stable, you would have lost money. I don't remember what that was off the top of my head. Anybody remember? She would have lost a set amount of money. Let's see, is it? And if the market contracted, you would have lost even more money. And that would actually help quite a bit if I could discuss the exact numbers with you. Somebody pull that problem up real quick. So the Carlisle tire.
The expand existing?
Yeah, so if you expand the existing plant and the market expands, it's $250,000. If you expand the existing plant and the market stays the same, what is it?
Negative.
You lose $50,000. Okay. If you expand the existing plant and the market contracts,
negative 75.
You lose $75,000. So you have three potential outcomes. Okay. You can make 250, you can lose 50, or you can lose 75,000. And those last two are in thousands. Okay. Under none of those scenarios are you going to actually make 15,000. What the EMV does is it gives you a way to assess, to bring the risk into your equation. So what you're literally doing is you are multiplying the potential outcome times the chance that that outcome will be the one that happens. Understand the difference there? Okay. And so I think when some of you were interpreting the test questions, I would ask about EMV and I would ask about actual value. And I think some of you may have been confused as to what I was asking. When I was giving you the actual value, I would give you the actual scenario. For instance, how much money would you actually earn if you expanded the plant and the market contracted? Okay. And then that answer would have been negative $75,000. What was the EMV of the recommended decision? That would have been $15,000. If you decided to build a new plant, what was your EMV there? It was negative $15,000. Okay. So yeah, so that is some of the, that was one thing I saw within the interpretation. I'm trying to think, what was the other thing that I saw you all doing a lot? Oh, a lot, you guys, a lot of you would mention EMV in your narrative without actually telling me what the EMV was. Like you would mention that the EMV of this was more than that, but you didn't actually give me the numbers. You've got to give the numbers. Okay, if the number is important enough to discuss, you need to actually discuss the number, not just discuss EMV. Does that make sense? Like I needed the number $15,000, or in the case of the parents and the drilling rights, I needed the EMV of 3.3 million. Okay, So make sure you're giving me specific numbers, not just throwing out that that number exists in the problem. So I would say those were the two most common mistakes that I saw in your writing. Does anybody have any questions? I see that some of our online students have joined us, so welcome. If you all have any questions, you can put them in the chat window. Do any of my face-to-face students have any questions in the meantime about that issue? All right, any questions about chapter 13 and your problems? Any questions about upcoming assignments, your book review, your, yes, Dalton?
Can we turn the book review in early?
Sure. Now, that does not mean I will grade it early, but you're welcome to go ahead and turn it in. Honestly, if I know that some of you are turning it in and I have some spare time, I'm perfectly happy to go ahead and get that off my plate and get it done for you. I just can't guarantee you that that will happen. Okay? So as long as that's fair enough, yeah, you're welcome. If it's done, go feel free to get it in, get that thing done. Okay. For those of you doing the project, another thing that came up this week, I had you write in that first discussion board, for those of you who are paying attention to the theoretical discussion boards, even though you don't have to, I had you give me 2 potential ideas for a project in case one of them didn't work out. You only have to do like 1 statistical test to answer 1 question. You don't have to combine 2 tests in 1 project. That clears things up for you. But sometimes you start on a project and you realize, oh, that won't work. I can't get the data or whatever. So that's why I wanted you to have 2 ideas if you were going to have to do the project. Another question Dalton asked earlier is, do I care what edition of the books you use for the book review? No, I don't. Okay. You can use an older or a newer edition. I do not care. I'd say whatever you can get the cheapest off Amazon or whatever the bookstore, or not the bookstore, but whatever the library has. You should all have access by this point, right? Everybody can see that book. Yeah. Okay. My online students, I'm not seeing any questions from you all. Can you hear me? Looks like you should be able to hear me. Let's see. All right, well, not getting any answers either way, so I'm going to go ahead and go on. If you guys are having a problem and want to email me about it, feel free. All right. Our problem tonight that we're going to go over is chapter 13, problem 22. I'll give you a minute to read it. All right. Have you read it? Okay. Anybody need another minute? Okay, give you another minute. Going to check my email real quick. Melissa, yes, we can go over 942 tonight. I think you are not the only one struggling with that one.
The last one.
I think so.
Yes.
All right. Yes.
Sorry. Address how to make the macro work at some point, and then when you copy and paste the template to another workbook, because for me it's like not. It's like
It's easier in these not to copy and paste it to another workbook. Yeah, yeah.
Move it, it's easy. And all the other spreadsheets into it.
Mm-hmm. Yep. Would agree with that. Yeah, so the question was, for those of you who may not have heard it, is copying and pasting the macro. There's not a good way to do that. So it is easier to bring the other spreadsheets into the template than it is to copy and paste that one. All right, are we ready to go? I'm going to switch to screen sharing. And all right, so what template do we need to use, guys? MMS. Why do we need to use the MMS?
Because the book says.
Because the book said so. You know what? That's a really good place to start. Did it say that in that problem?
Yeah.
Yes, it did. All right. Well, don't you love that? All right. If the book hadn't told us, how would we need it? How would we know we needed to use the MMS instead of the MM1?
You need to announce servers.
Yeah, because there's more than one server. You use MM1 when there's one server. More than one server, MMS. Okay? It's not too hard. I think that's a lot easier than some of the other stuff that we've done. All right, so here's our MMS. All right. So what is our arrival rate in this lovely scenario?
100.
It is 100. What is our rate per server? 50? Okay. All right. I'm going to go ahead and calculate steady state quantities, but it looks like, yeah, so I can't have two servers. Like what will happen is the line will infinitely back up. Okay. And the customers won't get served. This is what happens early in the day at Disney World, right? Line gets so long, people stop being willing to wait in it. This is what happens. They can't, more people arrive than the ride has capacity for. All right, so let's start with 3. It looks like we might be able to use 3 servers. So let's go ahead and calculate our steady state quantities here. What I'm going to do is I'm going to copy and paste this section into another workbook. So I'm going to copy and paste the values. Actually, I don't, in this case, I don't necessarily need the, I don't need the macro to run over here. Did I hit calculate steady state? Ooh, I don't remember if I did that. Let me look. Yeah, I must have, because nothing changed. Okay. You always have to remember to hit this button, the calculate steady state inputs. All right. So now I'm going to go and run it with 4 servers. Time you change that, you've got to rerun your macro because your numbers change a little bit. Okay, I'm going to copy these numbers, move it to my next sheet. Okay. Going to change it to 5 now. Calculate again. Okay. Copy and paste it. And I'm going to go to 6. I think 6 is the last one I'll do. If it looks like the cost continues to decrease from 5 to 6, I may need to go back and add more. But you'll see pretty quickly when you're doing these that you'll find a dip and then it just keeps rising after that dip. So as long as it's rising 6, then we don't need to go any further. Does that make sense?
What are you looking at for? Sorry.
I haven't calculated that yet, but I will. That's what I'm saying. I've got to go do. I'm gonna plug these in, and then I'm gonna go do the calculations. And if my in numbers make it look like they're still falling at 6, then if my cost looks like they're still falling, then I may need to add additional. Okay. All right. So what are our other inputs that I don't have plugged in yet? So we have the cost of servers, and that is $8, right? An hour. Okay. And we have the cost of waiting, and that's $20 an hour. Okay. All right. So our next question, so let's calculate the cost of servers. So this one's pretty easy. What number am I going to multiply? Or what two numbers am I going to multiply together? It's going to be, yeah, you know what? You guys can't see this, can you? Hold on. Better? Okay. All right. So my number of servers is 3, and we're going to multiply that by B1, which has the $8 an hour cost. I'm going to make that cell an absolute value so I can copy and paste. Okay. My cost of servers for the first one is 24. All right. My cost of waiting. This is the one that students struggle with a little bit more as far as which number to pull out of the model to calculate the cost of waiting. All right, to go about it. A lot of you want to pull either the expected number in the system or the expected number in the queue, okay? And we can do that, and I'm perfectly happy to do one like this. I'll show you that it ends up the same, whether we do the number in system or whether we do the right calculations with the expected time in system. So the first thing we've got to decide, though, does the $20 per hour waiting cost apply only to their time in queue, or does it apply to the whole time that they're in the system? And this is a little bit of a judgment call in most problems, but I would encourage you to go back to the text of this problem and read it closely. It's for the waiting in line, which is just what? The queue, okay? And they're pretty specific about it in this problem. Now, depending on whether they're looking at the system as in just like the queue is until they get their food and the system is the rest of the time in their restaurant, whether they're looking at is the queue is until they order and the rest of the system is until they get their food, that could be, you could make a different judgment call depending on what they mean by that. And so if you had a client that wanted you to run this problem, like you would need to go back and clarify. I had an experience at a McDonald's. We ordered, should have tipped me off because it probably shouldn't take 5 to 10 minutes to order at McDonald's. However, I actually wouldn't have been too upset about that. When it took another 50 minutes, not 15, 50 to get my food, I was kind of mad. Yeah. I had kids in the car. I had a baby at that point. She was screaming her head off. So my mother would say that serves you right for going to McDonald's to begin with. And but let's just say, like I said, had they said, hey, look, our time in queue is only 10 minutes, like we're good, we're golden, we're going to ignore the rest of the 50 minutes that it actually took to finish serving this customer, that could have been problematic. However, I digress a little bit. So the cost of waiting in this case is going to be done based on the time in the queue, not the entire system. All right. So the expected time in queue, but remember, that's only the expected time for one per person, okay? How many people are going through this queue in an hour? 100. And so you have to multiply that time per person by the total number of people, okay? Okay. And then that cost can be multiplied by the $20, which is the cost per hour. And I'll make that an absolute value, okay? Should be able to copy and paste that across. And then I'm going to sum these two numbers. Okay, so what's my best option? How many servers? You think 5? Yeah, I can, there we go. Does that help? Yeah. Yeah, we started at 3, so. Yeah, so 4, the 4 is the least cost, okay? So some questions, actually, let me go back. Let me show you the other way to do cost of waiting, okay? So I'm going to calculate it down here just so you can see that the cost of waiting would be the same way. If we just take the total number expected in the queue at any given time, and we multiply that by the cost of waiting, it actually should give us the same number, and it does. Close. I think that's just a rounding error. Yeah, there you go. It's just a rounding error. Okay. No, not if you use the number in system. So the number in system is effectively the time in queue.
Not the number, the number.
I'm sorry, the number in queue. Yeah, use the number in queue. The number in queue is effectively the expected time in queue multiplied by the number of, if you want to see that, I can show you that. So equals the expected time in queue times, I'm just going to put in 100 just so we can see, because we know that's the number. See how it's 0.8889? And see how that's the same number as the expected number in the queue?
So the cost of waiting, we can do this in every situation?
Yes, you can do, yes, instead of doing the time in queue times the number, it's always going to be the same as the expected number in the queue or the system, depending on which one you're pulling from. Does that make sense? Yeah. Okay, so you can get there either way. So I would say in this, find a way that makes sense to you and do it that way. I don't care which way you do it. So if the time in system times the number that are going through per hour makes more sense to you, by all means do it that way. If it makes more sense to you, you just use the expected number cells, then do it that way. All right. So let's talk about some things that I might pull out of this for test questions and how to interpret this thing. All right. I'd ask you, if you choose to have 4 servers, what is your cost of waiting? What would that be? $3.48. Very good. If you choose to have 6 servers, what is your total cost? $48. Okay. If you choose to have 3 servers, what is your cost per server? Or I'm sorry, what is your cost of the servers, not per server? 24. All right. So now let's get into some of these numbers. If you choose to have 5 servers, what percentage of the time will all servers be busy? 6%, yeah, this number right here. See where it says all servers busy? That's where you would pull that, okay? If, let's see, if you choose to have 6 servers, how many would you expect in the queue at any given time? .009, that's correct. If you choose to have 4 servers, how many would you expect in the system at any given time? Yeah. If you choose to have 3 servers, what percentage of the time is the system empty? 11%. Yep. If you choose to have 6 servers, what percentage of the people don't wait in the queue? 98.2%. Okay. So I don't feel like these are rocket science. I think this is probably the easiest thing you've done yet in this class. Yep. Okay. Questions on this? Some tricks with your homework. Were you guys able to figure out your homework and get the right answers on these from those? Sent them out Friday. Basically, the trick was the expected number in queue versus system, and then the expected time in system versus queue. We can address this. Let's talk a little bit about how would you know if it didn't tell you in the book blatantly. How would you know whether to use the expected number in system and the expected number in queue? And it's whether it's costing you money the entire time or just while they're in the queue. So let me give you a good example of what I think of both of them. So while you're at Disney World, are you aggravated while you're waiting in line? Probably. That's not the fun part. Although we could have a fun discussion about all the things that they've done to make their queues fun, right? There's some rides my kids actually get disappointed if they don't get to go through the line. Okay. Dumbo, for instance, where they have, how many of you have been to Disney lately? Okay. Not too many. All right. So they have their queue in Dumbo is about, let's see, they introduced it about the time my son was 5 to 6 years old. So what it is at a restaurant, they give you a pager. So you go through a short line, you get a pager, and you go into this air conditioning play area, indoor play area. And my kids, they love it. They're so mad if they go to Dumbo and the play area is closed. They're like, what do you mean we can't play? And so it's fantastic on a hot day. We'd never get a fast pass for that ride again. So so my kids are completely happy in line there. And so I completely digressed and I ruined my example. But for the most part, you're not enjoying the time in line, but are you happy while you're actually on the ride? Okay, yes. And so in that case, your critical value would be your time in the queue. That's where your people are unhappy. So there's an example, which we probably won't do, but on how long it took to fix washing machines, okay, and a laundromat. Are you losing money the entire time the washing machine is down, or just while it's waiting, they're waiting to start repairing it? Yeah, you're losing money the entire time it's down. And so then your critical value would be the time in system, not the time in queue. It doesn't matter how long it takes them to start repairing the thing. What matters is how long it takes them to finish repairing the thing. So a little bit of that is knowing your customers and trying to make sure that that you understand whether they're upset about. Going back to the Disney thing, they're brilliant guys in how they've done some of their queuing. They're absolute masters at queuing. Jack's shaking his head no. Jack, have you been to SeaWorld lately? No, yeah. If you go to SeaWorld and then go to Disney, you will see just how masterful they are at queuing. In fact, go to the fireworks at downtown Lakeland and see what a pain it is to leave afterward. And then you will understand just how masterful Disney is at queuing. They can serve more people in substantially less time than almost anybody else I've ever seen. So is it a pain in the butt to wait in lines? Sure. None of us enjoy that usually, but they're absolute geniuses at moving people and queuing. But it's some of the things that they've done to make even the queue time more enjoyable is the Dumbo thing that I mentioned. And, or a lot of their queues are becoming increasingly interactive. Anybody ride Space Mountain lately? Yeah. What do you do in the Space Mountain queue? You play a video game. As you walk through the Space Mountain queue, you are playing a video game. Okay. They've added all kinds of interactive features in their queues to make the queue time itself a little bit more enjoyable, to help offset some of this aggravation with waiting. Okay. Sometimes that's more successful than others, but it at least is a good attempt. I wish they would make every ride like the Dumbo ride, where you got to go sit down on a bench and watch your kids play in the play area while you're waiting for the line. The ride. It's beyond brilliant. Outside of Disney, what are some things that other businesses might do to help with problems with queuing and maybe shift some demand around? Yes.
They give you their phone number, and you can go walk around downtown.
Okay.
Wait for a text to come through, so you're not actually sitting there waiting for your turn.
Absolutely. Okay. So for online students who may not have been able to hear, some restaurants, you give them their phone number, you give them your phone number, and instead of having just a pager where you're stuck close to the restaurant, you can go walk around downtown and then they'll send you a text when it's time to come sit down and eat. Okay. So that definitely can make waiting more enjoyable. What are some other things that they do? How many of you like to go to Applebee's? Anybody an Applebee's fan in here? No? What?
Only the half price advertisers.
Only the half price appetizers, but that's my point. When do they start? 10 o'clock. Is that rush time for the restaurant? No. So they get, so when do you tend to see the best promotions for a restaurant? During their slow times. So what they're doing is they're shifting some of their demand from their high volume times to their low volume times in order to like keep their servers busy and stuff. They probably don't need to offer you a promotion to come eat at 6 o'clock in the evening. Okay. If they do, they're probably not a very good restaurant. But at 10 o'clock at night, you know, when they're fairly empty, that's the time that they are doing their better promotions. Or what would be the early bird, right? The senior discount at 4 or 5 o'clock, which again is a slower time for the restaurant. So that's some of the decisions you can start looking at from this queuing stuff is how could I bring more tellers? How could I potentially shift the demand around some so that maybe I don't need to hire so many people? Could be an actual real world application there. All right, I think we've got about as much out of this as we can, unless anybody wants to do anything else with the queuing. Going once, going twice. All right. So I'm gonna guess some of you have a homework problem you want me to help you troubleshoot? Yes, I see that hand. Okay. I think Josh, you already sent me some, right? My proactive. Okay. So 942.
And 468. Dalton and I argue two different numbers, and we both were right.
What's answer check say?
Yes, that doesn't logically make sense to me.
Well, we'll look at it. All right. Was this the right one? Yes. Oh, okay.
That's where I got started.
Yeah.
I have no idea. Coming up, starting.
Okay. So we do bays here. I think these bays numbers look a little bit off to me. Is that
the success and failure at the multiplication one?
mm-hmm.
That's given, right?
Let's see this 942. Let me go. No, you've got to factor in the 40% there. So you would be multiplying for the successes. Success was 0.4, right? And failure was 0.6. Okay. So you would be I need to enable editing. You know what? I have not brought up precision tree yet. And the other thing I'm thinking is I bet that my online students may not be able to see this sheet. So hold on. I'm going to stop in and share that window. There we go. Okay. Hopefully online students can now see this window that everybody else is looking at. All right. Going to enable editing it. I don't have my decision tree plugin enabled, so the decision tree is not going to work, but I can we can get the bays right, and then I can discuss the theory behind the decision tree for you. Okay. So your successes, Instead of just C5, it needs to be C5 times 0.4. Okay. And make that so that my column can shift, but not my row. I'm sorry, my row can shift, but not my column. There we go. That's not right. Okay. C6. Okay, because these are spread out differently. Okay. So that's fine. I can do these manually.
The online students can just see.
They can just see my face. Okay. Thought I did screen sharing. Thank you for letting me know. Let me try to fix that. Screen share. Application window. All right. Does that work? Can they, online students, can you now see the, no?
Yes.
Yes. Okay, perfect. Guess I should have checked that one. Okay. So, I don't have a clean way to copy and paste this because of how, because the charts are set up. I mean, I could do a transpose, but I'm not going to do that. Okay. Okay. All right. Since these were all successes, I multiplied the chance of success by the chance of success within the population. So now I'm going to do the chance of failure within the population. Okay. These are looking more right to me. Yep. Okay. So Josh, you were really close. So you just missed that first step. You missed the multiply step. It did have to be done.
Okay.
Okay.
And that makes that part make more sense. And then for the decision tree, I know you can't do it on your computer, but can you go over like what are the decisions and what are some of those?
Yep.
It started like with one decision, but I can't
Sure.
think of.
Okay, so market research, yes or no? Yeah, so actually let's do the same thing we did last week. Let's outline what your decisions would be. So you've already have on here whether you do market research, okay? And you correctly identified that as the first decision. What is the other, there's one more decision. What's the other decision? I saw a hand over here. No. Okay. Yeah, to what?
Market it or not.
Yeah. Okay. Or to launch product or not?
Or sorry, to test the market.
Is there okay.
Oh, market research or to test the market or not. Or to launch the product.
Yeah, launch the product. Okay, that's what I was thinking. There wasn't.
Sorry.
Okay. All right, so market research is one. This is the only other one, so obviously it's going to be two. Okay, so what are your chances? What variables do you not have control over? Actually, I'm going to take this off. We'll factor the chances in.
Because this is favorable, neutral, or unfavorable.
Yeah, so outcome of survey. Or outcome of, is it market research? What is the term of the product? Market research, yeah. So you do not have control over the outcome of market research. And what else do you not have control over? Success or failure of product, yep. Okay, yeah, that was the other thing that that came up some in your writing. Some of you would say that your recommendation was to choose to expand the existing plant and have the market, expand. Well, that's great, but you don't get to pick that. Like if I could pick the highest stock return and pick that it was going to succeed, that would be fantastic, but you can't do that. And so that's why the EMV is important, so that it and the risk under uncertainty. So you have to correctly identify what you have control over and what you do not have control over. Okay. All right. So in your decision tree, the first thing that you would do is decide whether or not to purchase the market research. Next thing that you would do, and you have so let's do the yes branch. Assuming that you're going to go ahead and market the research. What is the next, or do the market research? What's the next step? The outcome of market research, yes. Okay. Right? What would be your next step in the tree? Launch product or not, yes. Okay. And so then the last one would be the success or failure of the project. Okay. So this would be the order. These are the order for the yes branch of the tree. If you don't do the market research, if that is a no, then you just don't have the outcomes of the market research. So your first decision would be market research, yes or no. Your next decision would be launch the product, yes or no. And then the outcome, if you didn't launch the product, then you're just done. And then your outcome, if you did launch the product, you would have success or failure. Does that make sense?
Say that one more time.
Okay.
So you said basically we're just skipping that outcome of market research.
Right. So for the no side, you are skipping the outcome of the market research because you didn't do the market research. So you're going right to not, and then success. If you launch, then it's success and failure. Okay. Does that make sense? Okay. There are other questions I can answer on this model? Going once, going twice.
Check does the base.
Check the base. Okay. Spoiler alert, you have to be able to do Bayes for your test this week. Now, I was not mean in that you don't have to do an entire model with Bayes. You just, I mean, as your extra problem. Your extra problem is on Bayes though. You have to be able to create a Bayes equation. There are other questions on this. Are there other models you want me to look at? Oh, you said 468? Okay.
That's the one that we emailed about and talked about earlier. Yeah, Dalton has 118,000.
118,000?
That's the one that reached success.
Okay. Dalton, what do you have for processes 1 and 2?
What do you mean, like labor hours and training?
Yeah, no, how much do you produce on process 1 and how much do you produce on process 2? Is it 10,000 and 5,000? No.
His is different because his is looking at unit ounces produced, and I did by units produced.
Oh, gotcha. Okay. I want to. Okay. It's having issue. You know, you can only run so many one time. So Let's see. See if it'll let me do it now. All right. All right. So 1, 3 else. Process 2. For 2 units of labor, 3 units of chemicals into 5 ounces per frame. Okay. $3 to purchase labor, $2 to purchase chemicals. Next purchase.
Could you move it over?
Oh, yeah, sorry about that, guys. Okay. So your labor, some product, B13 times B2, okay. So some product is processes times chemical. Ounces sold should be 5, okay. Oh, I see one problem. You don't have a decision cell for how much of Jenny's hours to buy.
But is that
Yeah.
is that really a decision?
Yes, it's a decision. Because you want, because did it give you a max available? I mean, because otherwise, how would you come up with that number? How did you come up?
with the ounces sold, and the question said, CKC believes it can sell 1,000 ounces of perfume. To simulate the demand for Leslie, CKC can hire the beautiful model, blah, blah, blah. Jenny is, so I did the amount of, to produce minus 1,000, and that's what she was used for.
Okay.
Or she could be used.
I think that that's one of the issues to be a decision cell. You're supposed to let Excel optimize the number of hours that Jenny, that you purchased from Jenny. Okay.
So do I make that a decision cell and a decision cell and I'm gonna say.
Yeah. You make that a decision cell, and then is your model increase. So it would be this 270, and then it was 200 hours, 200 units, 200 ounces, right? For every hour.
Yeah.
Yeah. Okay. So there's circular reference here because so then your ounces sold this should be ounces produced, not sold. Because you've got to, over here, we'll calculate your demand. Okay. I'll put a line here. So you've got to constrain it so that you don't produce more than the demand. So the demand is, do you have the 1,000? You don't. Okay. I'm going to put it up here somewhere. So E1 plus, and then it is the amount of hours. Actually, it could just be the model increase. Okay. And then this needs to be 1,000 and properly labeled, which I did not do. And
Okay, what was your Excel reference or the formula for ounces produced demand of the demand?
it was just the increase from the model plus the 1,000 that would have been demanded without the model.
That would be less than equal to.
Mm-hmm. Yeah, because you don't want to produce more than that in demand.
And the model increase is just ounces produced. Here.
The other thing I see is that you didn't you put in the cost for the model and the profit for the perfume, but what are you missing?
For the model.
Yeah, cost for model was B20 model hours times the cost for Jenny. But is that your only expense here? Yeah, you had that. Seen another cost. What's the other cost that you're missing?
Oh, labor.
Yep. Okay. So that's going to be a sum product of your processes and the cost. Okay. And then this needs to also subtract out B23. Now I have
Your
okay.
B19 formula.
What's my B19 formula? It's just the number of hours used times the amount of increased demand per hour. Now, is that 200 in units or is it in ounces? Thinking it was ounces, right? Yeah, 200 ounces. Also, is this a min problem or a max problem? Yeah. She did have that.
I came up with 208 now.
Yep. And that's still not what you had, right, Dalton?
I have 118,000.
118,000, yeah. So we're still missing something. Are we missing any more costs? All right. Let's
So,
use,
purchase of chemicals.
I'm sorry,
Purchase of chemicals.
purchase of chemicals. That would do it. Okay. Okay, so some,
Well, some product actually won't work though, right? Because if
why?
I did cost of labor and cost of chemicals, so I would need to do a sum then multiplication.
I'm not. Oh yeah, you are correct. Oh, you know what? We may have done labor wrong. Hold on. I did a sum product and that's not right. So we can actually, it doesn't matter whether we use the labor for the, yeah, it does not matter whether we use the labor for the fixed rate. So we actually already have that calculated. So we'll go back and fix that in a minute. All right, so the cost of chemicals is, it's $2 per chemical. And so we need to fix the labor. So I did that one wrong. It's just a simple, okay, we're summing the $20,000 or 20,000 units of labor times the cost of the labor. And taking out the cost of the chemicals. There we go. Now we're getting it. Notice that interestingly enough, how much we were producing and buying of Jenny's labor didn't change, even though we were wrong down here. But if you went to your boss and said, if you enact this plan, you're going to make $240,000 and they only made $118,000, would they be happy with you? No, even though it was the same plan either way, like they couldn't have done any better. But just the fact that you'd set the expectations up here and then you came in like that would probably not have been a pretty moment with your boss. So it's still important. Okay. All right. So I think we finished this model. Does anybody else have one they want me to look at? Online students, I will check. And if you've emailed me one, I don't mind looking at yours either. All right. Mitchell, you've got 668. Or I'm sorry, 468. Let's see, we can figure it out. And I think then I have to go back in Google Hangouts. I don't like this as well as the join me. The problem is my it's free trial and join something else. All right. I think this one's yours. And looks like you should be able to see that now. Okay. Let's see if we can figure out what's wrong on this one. The gross profit immediately looks just a little bit low to me. Well, that's because you're not producing, oh, enable editing. That's because you're not producing anything on line 2. So let's see if I put the right value for line 2 in. No, it's still not right. Okay. Are we converting this to, oh, no, okay. So that is now the correct gross profit. Okay. Any cost is a little bit low. Be less than or equal to, put the right numbers in. Putting the right numbers in, I'm getting the right answers. So that means there's a problem in constraints somewhere. That number looks wrong to me. So let's see. I'm going to go back and look at JASA. So this 69,000 number does not look right. No, so the demand should be 55,000. So let's see. What did you do? You did 270. Oh, okay. Yeah, so this amount produced shouldn't be in there. It should just be referencing the 1,000, which is the original demand without Jenny. So that's now accurate. Now, you couldn't get a sensitivity on that 1,000, but let's rerun solver and see if, actually I'm gonna zero these numbers out so that we know if it worked or not. All right, yeah, that was it. So you just had a little mistake, Mitchell, in D13. You did not want to put, you had this sum of the amount produced in there instead of the 1,000 that was originally demanded. So once you fix that, your model worked fine. Right? See if there's any more. You just sent me one, okay? And looks like the screen share didn't work on that. Sorry, guys. So let me go back to the screen share on that one. So Mitchell, I can actually show you. So it was this, I'm hoping you guys can see it. Yeah, okay. Hoping you guys can see it. So it's this number right here, which you had as instead of the 1,000, that was the base demand, you had referred to the sum of the amount produced. And so that was throwing the model off. So once we got that fixed, it worked fine. All right. Going to go back and grab Kristen's model. Which one are we looking at for you, Kristen?
1321.
1321.
Online, so yeah.
Okay, but we're looking at 1321. Got it.
That one, the answer, it was asking for two answers, like
Yeah, I'm not sure.
the best solution and expected time in Q. So, I don't know.
What was the expected time in queue of the best solution? So you had identified the best solution and then put the expected time in queue. Okay, I will look at it. It didn't come up. Hold on, don't know what happened there. May need to shut Excel down. It's not coming up.
I have it on mine. That
You-
helps.
You have it on yours? No one else can see it then.
No, you have mine pulled up.
Oh, I have yours pulled up. True. But I want to look at Kristen's and see, try to help her. All right, now it looks like it's pulling it up twice. Okay, so. Okay, that one looks right. So your arrival time for the finance is 20, service rate is 25. Marketing is 15 per day and 25. If you pull them, then. So you actually did 2 servers. Which, did we calculate steady state quantities with this? Okay. To enable content, okay. Okay, well, we are gonna trust you on that. So this looks right to me.
Got the same numbers and the 0.029, 0.404,
And
like
the
all
exact
that
same
was the
numbers
same
too.
as the check.
Yeah, I think this looks right to me. So let's talk about the interpretation of this one. So if we, let's go back and look at the finance. Actually, let me make sure my online students can see this, and they can't. Sorry, guys. I will get this. So screen share. Not sure. Is it moving for you guys? All right. I think it was this one. All right. Hoping that works. Okay. The finance department, let's talk about the interpretation. how long, okay, first of all, what's your critical number? Is it the number, is it the time in system or the time in queue? That would be critical here. Does it matter how long the letter waits to get started, or is it how long the letter it's until it's all the way done? Is the letter of any value to you if once it's started, once they've started typing it? Just started, not finished? No. No. So really the value comes in when it's finished. So this would be a total time in system, right? Because if they only finish half your letter, it's not like you can send that to your client, right? So time in system is your critical value. So this is per day. So 0.2. So it takes 0.2 days for the finance department. The marketing department is even as I'm sorry, they're same typing rate, but they have less letters, so they get theirs a little faster. So it's 0.1. Okay, they wait 0.1. All right, but if you pool them, what's our hypothesis? Is it better for one or both? It's definitely going to be better for marketing, right? I'm sorry, for finance. Is it going to be better for marketing too? You think so? All right, let's look. All right. So the expected time in the queue is 0.038. So pooling them actually works better for both departments. This is what we like to call a win-win. Okay.
But aren't you looking at time system still?
0.078. Yes, thank you, Josh. I just pulled time in queue. Still better, 0.078. Still less than 0.1, which is was the best of the two. Still a win-win. Thank you for catching that.
The answer check is still saying, I put that in and it's still saying it's wrong.
The answer check is saying that 0.078 is wrong.
Yeah.
0.078.
What is the best solution? Time in the queue. That's
Expected time in the queue.
that's what he's asking.
So time in the queue is specific. It's not
It's not the system.
Yeah, but not 0.03.
3, and that's still wrong. Okay.
Put 0.0.
You tried all that? Okay. Well, this model is correct, so I can alleviate your fears there.
Okay.
If you know what, just on the off chance there's something wrong with it, let me pull it up. But I'm pretty sure it's right. It's what I remember it being. Yeah, it's right. 0.078 and 0.038. So 0.078 is not right either. Okay. All right, other questions? Yes, Josh.
39, sorry.
I just had a question on.
Okay. Okay.
I'm wondering where you went from the MM1 to MS,
Why we went from MM1 to
how you did that. I'm not sure where you got the numbers.
Okay, we can look at that. So question is, where did we get the numbers for the pooled for the MMS? And so for this arrival rate, we just added the 20 and the 15, right? So, okay, so 20 arrived per day from finance and 15 arrived per day for marketing. So that's 35 letters total. And the service rate per server, they still do 25 each. Okay. And then the number of servers was 2. Mm-hmm. All right, so, and then you wanted to go over which
39. It may be that phase thing again, but
it is.
I did the multiplication and all that, and I'm
939. All right. So now I actually have to go back to the email. and pull yours again, Josh, because I deleted it without saving. Go me. All right. Josh, let's see. Oh, online, I'm not sharing my window again with you. Hold on. Let's swap windows. There we go. Yeah, Josh, same thing as before. You didn't put the 18%. You didn't calculate the 18% population in. So you didn't do your multiply step.
In the multi. Yeah, I did. In the next.
Oh, in the next one. Okay, I'm sorry. Just looked at that. Okay. Okay. 18% of the cars have problems. How many of the cars have no, what percentage of them have no problem?
Zero.
It has to sum to 1, right? So if 18% have problems, what percentage would have no problems? Right. And so you still referred to B2 in here when you needed the inverse. So if you did
You
one
multiply 0 times 18 equals 0.
for that one, but it's not for the next one.
The inverse of 18.
Mm-hmm. Because 88% of your population, cars in your population have no problem. But there's still an issue here because these aren't adding up correctly either.
Is the setup right?
Hmm?
I mean, the test posits, problem, no problem. I did difference, and when I do the adds, I cannot add as the same way he did.
Set it up differently.
Yes.
Okay.
I thought the top section had to add to 1 across the board, not the multiplication. Or does that still have to add to 1?
The percent that have problems should add to 1, and the percent, whether they test positive or negative, right here. And the percent that should be the same.
Okay, 'cause the top part,
Yeah.
that's where I was thinking they had to add to 100.
Yeah, no, that's what I'm thinking. You probably flopped some inverses up here. So let's read a little bit more closely. So the okay. All right. Okay, so here's the issue. So they test actually a problem not 88% of the time, but 12% of the time. So that's one issue.
That's what that 12% is referring to, and then the problem is
yes.
the inverse of that.
I think so. Let me look. So I'm just gonna correct these numbers here, and then I'll let you go back and link them to your formula appropriately. All right, so I'm gonna take these out too. So yeah, because I think you had the 100% in the wrong spot too. So then on the other hand, if an inspection never detects a problem when there is no problem. So there's no false positives. So in other words, it is never going to test positive when there's no problem. Okay, so no, it's not going to test positive for a problem when there is no problem. This one is,
You put that under a problem when there is no problem.
I'm sorry, I flopped that one, didn't I? Yep, see, easy to do. So 0% of the time they're going to test positive when there is no problem. That's what I meant to say, thank you. And so, no, that's right. When they I was right. When they test positive, 100% of the time, there's a problem. Okay, so it's never going to test positive and not actually have a problem. Does that make sense? So that's why this one's 0. If it tests negative, there's still a problem 12% of the time.
And that 88% should be 100%. Because it
Mhm.
inspection never detects a problem when there is no problem.
No. So the 88% here, if it tests negative 88%, they're saying when the test says it's negative 88% of the time, there's no problem. 12% of the time when it tests negative, there is a problem. I believe is what that's saying.
Does the inverse of the other one go across, not up and down?
It changes with every problem. So you have to look at what they gave you and think what's the true inverse. And that's where these things are tricky, is because it's super easy to flop the inverses and think one thing is the inverse when it's actually something else. Okay. Yes. Let me actually, I want to check the answers. I think we actually might have it. So this is 1339. Okay. 939. Sorry. Thank you. Or 257. so we're not quite, we're missing something.
My no problem test negative under multiplication is different than yours.
Your no problem test negative?
Yeah.
Okay.
You did the 1 minus. You did the inverse. Would that be it?
I should have done the inverse there because that was the no problem. So 88% of the time, so it should be 88% times 82% effectively.
And the two adding ones should be equal to 1, right?
Yes, these should be equal to 1. They're not. You're right. So there's a problem here, but what is it? So if we flopped more inverses,
If I was checking on the answer check, it has a hint that 84.16% of vehicles pass inspection.
84.16, thank you. Let's note that. 84.16. Yeah, that sounds right. So for some reason we are too low. So I'm assuming that our add is correct. The 11, 12, yes. So that formula is correct. So something's still wrong up here. Here.
Did you do the 1 minus? Did you do 1 minus the 18% or 1 minus the 88%?
Did 1 minus the 18%, which would be 88, which would be 82%. Yep. So that's B2.
That was able to get that number, but she inversed the 88%, right?
She inversed.
Like where your cursor is.
She did 1 minus 88% times. It doesn't make sense. All right. No problem found. Inspected car has no problems. Okay. So our inverse there is right. Inspected. So problem found. Inspected car has problems. Oh, we flopped these. That's what we did. So wait. Test positive. And there's actually a problem with 100% of the time. Okay. 12% of the time. Problems up here with these 4. Okay. That should be right. Okay, so test negative, and there is no problem 88% of the time. Fails to detect a problem 12% of the time. So test negative, and there's actually a problem. Test negative and no problem. So that is at the time. No, that we've done something wrong with the inverses. Okay. Fails to detect problems 12% of the time. That should be. Not actually a problem. Test negative. All right, I'm gonna take these back out. %12 of the time, test says no problem and there is a problem. Okay, 12% of the time. Okay. Never detects a problem when there is no problem. So that's going to be 0%. So, okay. When they test negative, okay, there we go. One. Minus. There it is. So I flipped inverses. Super easy to do.
And so then we inverse the multiplication as well. And that can depend on, depending on.
Yeah, it depends on how they word it. And so what they gave us was this one, D7, and they gave us C8. And so then you had to think through logically, is the inverse here, is the inverse here? And I missed it when I did it. But that, I will tell you, when I do these, that's my biggest area for mistakes, is that it's so easy to flop these inverses.
But in the next section down in multiplication,
Mm-hmm.
you also do the inverses too. So theoretically, I can't copy and paste all this for a new problem, plug in the numbers up at the top, because the inverses where we did it for like the no problem, that would change what the inverses are, right? Or is it always going to be that inverse?
It's always, the inverse for problem and no problem is always going to be tied into whether the actual rate of cars that have problems or not.
So in the no problem, and the multiplication part, the no problem, the bottom line, the 0 and the 82,
Mm-hmm.
are those always looking at inverses, or are they, do we always use the inverse for that, or does that depend on the problem?
No, you would always use the actual population, the occurrence in the actual population. That's an easy inverse to figure out. So you always look at, well, you would look at what they gave you. If they said 88 or 82% of cars have no problems, then you just have
The inverse is the other one, not that one.
right.
It depends on the problem.
Right. It would depend a little bit on the problem, but to me, it's easy to get these confused if you're not paying super close attention. It's not as easy to get these confused. It's whether or not it occurred. Okay.
Didn't get it in the answer check. But there's that answering.
It's not answering that way in the answer check.
2.57, 2.5, 2.6.
Is there directions as to how to input it?
Right? It's 100.
100. So it should be, yeah, so it should be 2.57. Try it without the percent. But that is the correct number, is 2.57 or 2.57 or 2.567. Yep. Okay, so they did not,
Yeah, I know.
I'm sorry. Are the answer checks more frustration than they're worth to you guys? I mean,
It's confusing because even if you have the right answer, it may not. So then you try to figure out what's wrong, and then it adds more confusion because even if you have the right answer.
so as the answer checks sit right now, would you rather not have them at all, or are they better in their? even in an imperfect state.
So we can see if they're right, because I feel like I always feel better when I come into.
Yeah,
class.
unfortunately, I don't always have the ability to see them myself until students submit problems. So yeah, that's fun. So I might hit the right one, like I might hit the right combination, but it still may not work for you. So, yeah. But I will keep that kind of in the back of my mind and figure out how we can work it. Like I tell students, you guys are reaping the benefit of feedback from future students. My ability to make change literally within an 8-week session is incredibly limited. But I take the feedback that you give me, and then you're paying it forward. So you're, like I said, you're reaping the benefits from future students, you pay it forward, and we continue to make changes and adjust based on your feedback as well.
It almost helps to bring the problems to class.
Mhm.
Because then, like, as we're doing this, we're learning the problem, we're learning how to work the problem.
Yep.
And at the same time, we're double checking the answer.
Double checking answer checks. Yep. That's why we decided to do it this way. So glad it's helping. All right. Anything else you guys want me to go over? I'm so sorry that my chat didn't work for you guys. I will do my best to figure that one out. I don't see any more models that were emailed to me, so gonna assume online is good. Face-to-face, I'm not getting any other, so I'm gonna go ahead. Last call for any questions. Going once, going twice. All right, I'm gonna go ahead and end the session. I will be available for individual questions.